When a tertiary or secondary alcohol is heated with an acid such as sulfuric acid or phosphoric acid, an alkene is produced through a mechanism called the E1. We can see here an example in which tertiary butyl alcohol is heated with sulfuric acid to produce 2-methylpropene and a molecule of water. The elimination of the elements of water from the alcohol to produce the alkene is believed to be a stepwise process, which begins with the protonation of the OH group to form the OH2 plus leaving group, which then breaks off to form a carbocation. This carbocation then loses a proton from the beta position to produce the alkene product. And since the acid is consumed in the first step and regenerated in the last step, the mechanism is then catalytic in acid. Since we are at low pH, the first step will be protonation of the weakly basic hydroxyl by the acid to produce the alkoxonium species. This step will be fast and reversible. The endothermic rate determining step then follows, in which the water leaving group breaks away from the alkoxonium species to produce the tertiary carbocation. And since this reaction involves only the breaking of the alkoxonium species, it is therefore unimolecular. The unstable carbocation will then lose a proton from the beta carbon, typically to water as the solvent, to reproduce H3O+, and give us the major organic product, which is the alkene. In conclusion, when a secondary or tertiary alcohol reacts with an acid such as sulfuric acid or phosphoric acid at high temperature, an alkene is produced. This overall is the loss of a molecule of water from the starting material to produce the alkene product. The reaction is known to be catalyzed by the acid and is described as the E1 process, in which the rate determining step is collapse of the alkoxonium species to produce the carbocation, which is a unimolecular step.